Welcome. In this video, I'm going to talk about empirical formulas. So we've been working a long time this year on learning how to write the correct chemical formula. That's when you know what's in it, and when it's in a predictable ratio like ionic compounds where they have to gain and lose electrons. But the reality is many covalent substances especially, and transition metals, can combine in more than one way. So how do you know which way it's combined? Well, you have to do some analysis of the substance you're interested in. And this is done all the time in forensics, in toxicology, pharmaceuticals, even in businesses like cosmetics and food. Businesses are constantly trying to see what their competition is doing. So in an empirical formula, you work backwards from you have the compound, you analyze it to see what elements are in it, and then you try and figure out the ratio or the formula for that compound. So an empirical formula is a chemical formula that shows the simplest ratio of the elements in the compound rather than the actual number of each kind of atom. So an empirical formula is the first step toward figuring out what an unknown substance is. So empirical formula can be found if you know the mass or percent of each element in an unknown compound. Now, we don't have the equipment here to actually analyze a compound, but you see it all the time on TV shows. They use these spectrometers, and they put the equipment in, it does some testing, and it spits out what is in it and what percent it is. So that piece is actually pretty easy to do in the lab. It's just really expensive. But it means you know the grams of each element, either with the mass, or if it's percent, you could just change percent to grams because it's from a 100-gram sample. So what you need to do is you need to chart out by changing to moles. How come? Because a formula is telling you how many atoms are moles, not how many grams. So from the lab, you're going to know the mass or the percent, which is the same as the mass in this case, and then you're going to work toward a formula. For example, C14H10O4 is the actual molecular formula, something called benzyl peroxide. But the empirical formula would actually be simplified or reduced to C7H5O2. So how do you figure out the empirical formula? Well, as I said, the first thing you're going to do is divide the mass of each element by its molar mass and find the moles of each element. And if it's in percents, just change it to grams, and that will add up to a 100-gram sample. The second step is you're going to write the chemical formula using those moles that you got from number 1. And it's going to look funny because they're going to be decimals. It might not even be over 1, but that's okay. Then you're going to divide each of those subscripts by the smallest molar amount that you had, and you're going to get new subscripts that should be very close to whole numbers. You should be able to round off like 1.98 and say close enough to 2. Sometimes they're not all whole numbers. There'll be a fraction like 0.25 or 0.33 or even 0.5, 0.67. In that case, you have to recognize it's a fraction of 1/4 or 1/3 or 1/2, or here we have 2/3 and 3/4, and you multiply by the whole number. But those are fairly unusual. Most of ours are going to fall into these first 3 steps as I have written. So let's look at an example. It says, find the empirical formula if a compound contains 40% sulfur and 60% oxygen by mass. So step 1 is change these into molar amounts. So I'm going to think of my percents as grams. 40 grams of sulfur then. If I want to change grams to moles, I put moles on top, grams on the bottom. I look up sulfur and see that it has a mass of 32.07 grams in 1 mole. So when I divide, I'm going to get 40 divided by 32.07. This is 1.25 moles of sulfur. If I do the same thing with my 60 grams of oxygen, I have to put mole on top, grams on the bottom, 16 grams in 1 mole. I get 3.75 moles of oxygen. Now you might be able to see the relationship between these two, which is good. I tried to pick one that would be easy to see, but I'm going to write my formula as S 1.25 O 3.75. That's my second step. My third step now is to go ahead and divide by the smallest amount, smallest subscript I came up with, which is the 1.25. And when I do that, I get S1O3 or we would just write it SO3. And that's my empirical formula. So here's one for you to try. You have 10.89% magnesium. Let me get you started here. You have 31.77% chlorine, or 31.77 grams of chlorine, and you have 57.34 grams of oxygen. So go ahead and see if you can change them to moles, write your formula with the subscripts, divide by the smallest subscript, and come up with an empirical formula. And you might want to pause as I continue to do the problem. So magnesium, I know 1 mole is going to have a mass of 24.31 grams. So this means I have 4 point, oh, I've got something in there wrong. I've got 10.89 divided by 24.31, a little less than a half, 0.448 moles of magnesium. With my chlorine, weighs 35.45 grams, so when I divide my 31.77 by 35.45, this is also slightly less than 1, 0.896 moles of chlorine. And my oxygen, I didn't do my spacing very well here, at 16, 57.34 divided by 16 is going to be 3.58 moles. So now when I write my formula, I'm going to write Mg 4.448, I'm sorry, Cl 0.896, O 3.58. Now we know that's not what any formula looks like because it has to be whole numbers. But now when I divide by my smallest subscript, 0.448, hopefully I will get whole numbers for each of these. Mg is going to become 1, Cl becomes 2, 3.58 divided by 0.448 becomes 7.99, which is close enough to 8. So my formula is MgCl2O8 is my empirical formula. Here's one more for you to try. So again, I'd encourage you to pause it and see what you can do. So 18.42 grams of nitrogen. If I convert that to moles, 1 mole is 14.01 grams. So 18.42 is going to be a little over 1 mole. 1.31 moles. And oxygen's the only other substance. So 31.58 grams of oxygen. 1 mole is 16 grams. So this is going to be right about 2. 31.58 divided by 16. This will be 1.97 moles of oxygen. And now when I set this up, N 1.31, O 1.97, divide each one by the 1.31. This time I'm going to get one of those fractions I mentioned. I have N1, but 1.97 divided by 1.31 gives me 1.5. And what that's telling me is that this doesn't occur in a 1 to something ratio. It's 1 to 1.5. So I have to multiply the whole thing by 2, and my formula is actually N2O3.